All right, guys, welcome back to another fun-filled week of uh, learning more and more about object-oriented programming. So today we're going to finish off, I hope, finish off the Chapter 9 slides about object-oriented programming, objects and classes, and get into the chapter 10 slides about how to think, the thinking in objects, like object-oriented thinking. Okay, so we're still just kind of like laying some foundation of kind of the general aspects of object-oriented thinking, but it's still an important foundation that I want to be able to yeah, so I wanted to be able to introduce you guys to these concepts. One thing I realized that I need to go ahead and do here is I forgot to do a quote of the day, I think, last time. So I'm going to go ahead and share that. Share. This is one of my favorite quotes, but also my favorite. Let's see. There we go. So this person, Grace Hopper, she was a rear admiral in the United States Navy. She was the inventor of the first compiler. I would love to claim that my daughter Grace is named after her, but I actually didn't even know about Grace Hopper until after my daughter was born. But she gives us a quote today, and I would suggest just Google search her. She has a fantastic story of how she came to invent the first computer compiler, where back in those days the computer was simply a calculator. All it could do was do some simple arithmetic operations. But Grace Hopper comes along and she says, "I think we can write programs for this calculator thing." And a lot of the not quote unquote knowledgeable people of the time told her computers will never be anything more than a calculator. They will never run programs. And she said, "We'll see about that." So she decided to try to create a compiler to be able to run programs on a computer, and look at what we have today. So we can all thank Grace Hopper for getting us to where we are today. But the quote she has today is, if one ox could do the job, could not do the job. So if one ox wasn't strong enough, or if it couldn't do whatever it is we wanted it to do, they didn't try to grow a bigger ox, but they used two oxen. So they put two animals, like if it was a horse or an ox, whatever. You take two animals to try to get the job done. When we need greater computer power, the answer is not to get a bigger computer, but to build systems of computers and operate them in parallel. So if you know, most computers today, you have multi-core processors, right? That don't, not just one single processor running tasks. And so it's not always, the answer isn't always just get something stronger, get a single thing that's stronger, but sometimes try to get two people together, two things together. So if, for example, I needed to move a couch, I wouldn't go to the gym and try to work out my muscles and get myself stronger so that I could lift the couch. What I would do is I'd call a friend and I'd say, "Hey, can you come help me lift the couch?" All right. And in the same way, the reason why I use this quote today is because object-oriented programming is kind of like this, is that we had sequential programming. We had a lot of things that we could do with that. And then when we found that we needed to be able to do things in a much more rich way, in a way that would allow for us to really classify things together, like make objects, basically, to make code that kind of would group together. We didn't say, let's just take sequential programming and try to manipulate it into making this thing happen. What we did was we said, hey, what if we think about programming in a slightly different way? And that's why that's how we have object-oriented programming today. All right. So, what the takeaway from that quote and my little philosophical speech just now, the takeaway could be, just because something has always been done a certain way doesn't mean that it's the only way to do it. Be thinking outside the box. Be thinking of new ways to be able to solve old problems. All right. So let's continue on. Let's see. Let's see. We were on 16. Yep. Okay. So this is where we left off. Was we talked about how to. I think this is where we left off. Was how to create a new object. So we have a class called Circle, and we looked at that example in the code on my IDE last week. And what we had was we have this class called Circle that's defined. This side, and I did this through the whiteboard as well, this side, we create a new object of that class type. This side, we create a variable that can hold an object of a certain type. And then we assign it this way. And I showed you kind of how that does in memory and what goes on in memory to make this thing happen, to make this assignment happen. In a lot of ways, this is just like any variable with a primitive type or a string like we talked about last semester. So there's a lot of similarities to stuff you already know. But I wanted to make sure you understood what each side is doing, because when we start getting into in future weeks, when we talk about inheritance and what's extending, like extending object types, or sorry, extending class types, this is going to become important, because here this circle and this circle, right? They don't always have to be the same. So it doesn't always have to be circle, my circle equals new circle, because as long as this variable can hold something of this type, that's okay. It doesn't have to be the exact same thing. We're going to see that in inheritance later, but I do want to kind of introduce that idea, okay, for the future. But for now, just know that this is the variable type. We're saying I want a variable called my circle that's of type this circle, and I want to assign it a new circle object. Okay. Now, when we create an object, we want to be able to get to some of its parts, to its data or method. We've seen this with the string, right? We saw that with the string with the char at, or the character at method. We saw that with the length method in a string. You've seen it with the math class, with pi and e. Some other methods in the math class as well. So you've seen this before, you just may not have known what was going on. So the way that we get an object's data is we say the whatever the reference variable is, so my circle, dot, and then whatever the data item is, the variable item is that we're trying to get. All right. Such as my circle dot radius will give us the radius value of what is contained in the my circle object. Okay. This acts like a variable, like any old variable that we've used before. Okay. Now the method name, sorry, the method in getting an object's method, we take the reference variable, we call it, we say the dot again, but this time we need a method name and a parentheses, even if there are no arguments that are taken. Okay. And what I mean by that is you guys have probably seen, like when you use the string length, remember that we used an array dot length and we used a string dot length. Do you remember the difference? Somebody comment to the chat, to the class chat. What's the difference between the string length and the array length? All right. What's the parentheses? Okay. Right, array dot length and string dot length. Do you notice in Unus Emre, his answer there, that is correct, is the length for string didn't use the parentheses, but the length for array did not use parentheses. What that tells us is that for an array, length is a piece of data. Length is like a variable value. Okay? But for a string, length is a method. So they're not exactly the same, are they? They're not exactly the same thing. So a method, even if it doesn't take any parameters, any arguments, it still needs the parentheses. Okay, and we get at it just like what he showed us there, just like what Eunice Emery showed us there with array.length and string.length. Okay. All right, so that's how we get that method. So you've been using an object method all this time, ever since the second half, even earlier than the second half of the semester last year. All right, last semester. All right, so you guys are ready for this. All right. So here's some example, right? Here's an example. You create a myCircle. It declares a variable called myCircle, but it doesn't have any value. It doesn't have anything in it. All right. We create a circle of radius 5. This will look very similar to what we did last week, where I did it on the whiteboard. All right. And now we have a reference value that points to this myCircle object. We can create another circle. We'll call it your circle. We'll give it a radius of 1 because in this example, there is no value passed to the constructor, and so it uses a default value. Go back in the slides and look, and go back to the slides and look for why that is. Remember, there's 2 ways that we showed how you could have a default value. One was by assigning it in the constructor. One was by having it assigned when the variable itself is declared inside of the class. So either way gives you a default value. All right. So we create a new circle, radius 1 equals that. So now we assign that reference value to this circle object. And then here we can set the radius to be a new value. It acts just like a variable. It's exactly the same. Now, you've already used a method before, like the POW method, where we give it 2 arguments, a value like 3 raised to the 2.5 power, right? Now, can we call a method like simple circle dot get area? Unfortunately not. And this has to do with a couple of reasons, but this has to do with the way that the method was declared. It was not declared as a static method. Okay. The method like the POW method was declared as a static method. What that meant was we wanted to be able to use that method even if we didn't have an object. Okay. But get area is non-static, so we have to call it by using an object of that class. Give what values to Erson? I'm afraid I don't understand the question. You mean like give default values to the radius? I'll let you clear that up, but what a static method is a static method is something that we're wanting to be able to use even if we don't have an object. It's kind of like a general method. If you notice, one of the keywords that you use, the Java keyword that you use for all your main methods was static, right? Public, static, void, main, right? And what that meant was we wanted to be able to call the main method from your class even without an object, which we did, right? When you run it, it calls the main method. All right. Static methods we want to be able to have just for general purpose use. We want to be able to use them regardless of if we have an object. Non-static methods like the get area, we want them to be associated tightly. We want them to be able to associate with a specific object. So for example, the get area method, what is its purpose? Its purpose is to find out the area of a specific circle, right? And so what we want it to be is not a general get area, because we don't want to be able to just call get area without a circle that exists, because what's the area of a non-existent circle? I don't know. That seems kind of a weird concept. Maybe that's for philosophers to decide, right? That sounds like the what's the sound of one hand clapping kind of thing, right? If a circle doesn't exist, we can't find out what its area is. So we make a method like get area non-static, so that when we call it, it's specific to that object. Okay, we will talk more about that in the future on a different section. But just kind of as a heads up, this is why some methods we can call just from the class name. Some methods require an object to be called. Well, yes, if you like this one here, Erson, we passed it a value that set the radius value to 5. The reason why, the reason why the second one was 1 was because that was a default value that we set. If you want the default value to be 5, where this is set to 1, you just set that to 5 instead. So basically, let's see, this is, what slide is this? 20. I'm going to come back to 25, 26. What I want to do is I'm going to go back and show you. Here. So here, this is why the radius is 1 when there is no value passed, because this constructor is called if no value is passed, and this is saying, hey, the radius should be 1 for a default circle. If you want the radius to be something else like 5 or 23 or whatever, you can just set that value here in your class definition. Okay. All right. Continuing on. So now, when we create these data fields, right, we can reference them, right, using that dot extension dot, students s dot whatever. Now, unlike variables inside of a method, like inside of a main method, data fields will be given default values if we don't give them default values. So some of you may have seen before, if you try to run a program and you have like int some value, int age, for example, and don't ever set that to a value, and then try to use it later, the compiler will tell you, hey, if you try to compile it and run it, they'll say, hey, that variable might not have been initialized, right? Unlike that, unlike those variables, they will get a default value. Okay, so like an integer will have a default value of 0. A Boolean will have a default value of false. A character will have a default value of, this is what's called the null terminator character. This is an ASCII thing that basically it's a non-printable character that just has the value 0. Remember, character is an integer type, and so its default value is going to be a 0, and that's what this is in character terminology and ASCII terminology, is the value 0. A string will have the default value of null, which is not just an empty string, but is a specific value. Okay. All right. It's like it doesn't point to anything. So this is what a null value is that it doesn't point to anything. Okay. All right. So if we were to do this, right, we will not get an error. We will not get a compiler error, because because these do have a value. They have a default value. All right. So even though we didn't ever give it a value, these will have a default value by default. Okay. But a local variable inside of a method, so something like this, if we tried to execute this, we would get a compiler error saying this variable is not initialized. Some of you have probably run into this. I know, run into this. If you declare a variable, you assign it inside of an if statement, but you don't have an else section, and the compiler says, hey, this variable might not have been initialized, right? Or if you assign it inside of an else, inside of an if, and you try to return that value, the compiler says, hey, this might not have been initialized. Okay. So that is a big difference. A variable inside of a class, but not inside of a method, inside of a class, does get a default value. A variable inside of a method, a local variable inside of a method, does not get a default value. Okay. So make sure you know the difference there. Okay. Some differences here between variables of primitive and object. Remember, an object is a reference variable to an object in memory. A primitive type, on the other hand, just contains the value itself. So basically, when we create int I equals 1, for example, we just store in memory a value, an integer value. When we create an object, however, of a type, we store a reference to some other place in memory that contains our object. Public int, where are you talking about? Is it this slide or this slide, or the student one, this one? So if we were to do public here, that's mostly just, that's not about whether or not it gets a default value. That gives a, that's not about a default value. That's about what's called a visibility modifier. The public tells me who can see it. What we will learn in, I think it's in the next section. We will learn about visibility modifiers, and it's there's multiple types. There's private, public, protected, and default. Those are 4 different visibility modifiers. This one is what we would call the default visibility, which means it can be viewed by a lot of people, by a lot of things accessing the class, not by everyone. But what we will learn is, for security purposes, we will pretty much exclusively for reference variables, for variable data fields like this, we'll almost exclusively use private. Okay, but public is just about who can see it, not about what does it get a default value. Good question though. Let's see. Okay. So here, if you had a primitive assignment, right? I equals j. We take the value of j and copy it into I. So the value of j2 and copy it into I. Same thing here. Value of 2, copy it. So before, this is I and j's value. After this assignment, this is what happens. Okay. Object type assignment. We talked about this last week. I think I also probably talked about it in last semester some. Is if we try to copy an object to another, we don't just copy the radius value, for example, we actually make it point to the same thing. So here, C1 points to this circle of radius 5, C2 points to this circle of radius 9. After this, we take this reference value and copy that reference value into C1, which means now they both point to the same thing. We also talked about this idea of garbage collection. The reason why we have this whole garbage collection thing is that sometimes objects are no longer pointed to. There's nothing in our system that points to that variable, or to that object rather, and so we need to be able to clean it up so that we can free up that space for other things to be able to be used. Okay, so nice helpful thing that this Java does for us. Okay, you can explicitly assign, if you know that an object is no longer needed, you can explicitly assign the variable to a value of null to force the garbage collector to take it up. It's not typically something we do as programmers unless we know for certain that it will help make the program much more efficient. Right? But it is something you can do, that if you force an object to no longer be pointed to, it will get cleaned up by the garbage collection. I won't go too much into the date class, but it is useful. Date is useful for doing logs, for like creating log files. For those of you who were in the CSE 101 class last semester, you remember that one of those that last assignment was about reading from and writing to files, and one of the files was a log file. I didn't have you do anything with dates in that, but it is useful when you're writing logs to be able to have the current date and time, to be able to tell when something happens. We can put it into the log file and say, this is when it happened. Okay, so it's useful. Again, I'm not going to go into it too much, but you should be able to understand, what some of this stuff is like. So this is toString method is a non-static method of the date class that tells us what gives us some information about what date it is. Okay. All right. You guys have used the random class before. We talked about it last semester. Remember, we can actually, I think the way that we taught it last semester was the math.random. There is also, we did introduce the whole random class. Math.random, remember, the only thing it did was it gave us a value between 0 and 1, excluding 1. And then in order to get some value, in order to get like a value between 1 and 6, for example, we had to do some math manipulation, right? We had to do some calculating, right? And it was kind of frustrating because, a lot of times we want to be able to get values between a certain two endpoints and not have to do a lot of, funky math stuff with it, like multiplying by this value and adding this value and converting it to an int and all that. So it's nice that we have this other class, the random class, that will allow us to be able to give a random integer, or a random integer between 0 and n, not including n, a long, a double, a float. So we can get a random Boolean even. So yeah, we can get a random value of different types without having to do a lot of math manipulation. All right. So this is a new class for you to be able to use. Okay. Right. Now, if two random objects have the same seed, basically we seed this with to be able to have a new start value. All right, it really isn't truly random. And the reason for this is that in computing, nothing is truly random. Without a seed, what it automatically does is, if we don't tell it to seed by a certain value, then it's going to use the system clock to do it. So in theory, if two computers that both had the exact same system clock, both created a random object at the same time, they would produce the same random set of values. Okay. That's very rare, right? That would be, you would have to literally push the go button on the two different computers that were both started at the exact same time. You would have to push the buttons at the exact same time, right? So that's not likely to happen, which is why we can call it random, even though it technically is not entirely random. Okay, so again, but if we seed it with the same start point, then it will give the same sequence of quote unquote random values. Okay, and that's because in most of these systems, the way that a random number generator is done is there's actually a list of numbers that go from 0 up to whatever the highest integer is. I can't remember that exact value. And it just starts. It starts somewhere in that list. So if you were to say, I want to start with number 1, right? Then it would start with the first value in the list. You say, I want to start with number 2, it would start with the second value in the list, and so forth. So if we say, I want to start with the system clock, which is the number of milliseconds since depends on how the system clock is done. It could be the number of milliseconds since the computer was turned on. It could be the number of milliseconds since a certain time. Linux does the number of milliseconds since somewhere in 1970, January 1st, 1970, I think. All right. So if we start it with the system clock, which is the default, then it'll be practically random. Okay. All right. But this is another way that you can get a random number other than the math.random method. Point2D is something that we can use. The point2D class is something that we can use for representing a point in a two-dimensional space where you have an XY coordinate. All right. Distance between the point and another point. Right. So this is some different another class that can be useful for, especially for graphic interfaces, for graphic user interfaces. All right. All right. So we're going to, how much time we got? Okay. I think we may actually finish this set of slides before the break. All right. Now, instance variables and methods belong to a specific class. So this is the data and the methods inside of a class. All right. So when we have a class, we use that dot to be able to get the data and the method. But let's talk a little bit more deeply about this idea of static variables, constants, and methods versus non-static. All right. Again, static variables, static methods, they're not part of the object, right? They're not, they're shared by all instances of the class. Okay, so what we can use a static variable for would be for a value that we want to keep track of regardless of, and we want it to be the same value across all objects, right? So an example of a static variable that you may have run across would be the math.pi. So the value of pi is stored as a static variable in the math class. Static methods are not tied to a specific object, meaning we can call them. I talked about this before. Main is an example of a static method that you've written before. Trying to think of something besides the math class. Well, I mean, I guess the random.nextInt. No, that's an object. Because math.random is a static method. Can't think of any outside of this. I guess system.out.println. You know that one. System.out.println would be a static method in the system class. System.out class. Okay. I can't think of any outside the math class right now off the top of my head. I'm sure one will come to me during the break. So the way that we can make a variable or a method static is simply say it's a static method, kind of like you've done with the main method, public static void main. All right. So we'll give an example of this during our example time. All right. And I think what I'm going to do is if I can finish these slides before the break, then what we'll do is we'll do examples during the second hour, and then we'll go into the slides 10, the chapter 10 slides during the third hour. Okay. All right. So an example of a static variable or static method would be the number of objects, for example. We may want to have a variable called number of objects that when we create an object, we increment this, we add one to it. We say, I want to create another object. So I'm going to say one more than it was before. So when we create this object, we added 1 to this and made it 1. It was 0, we made it 1. When we created a second circle, we added 1 to it again, and now we have 2. And we want to be able to make the get number of objects a static method so that we can access it even if we don't use the object itself. Okay. I'll show this as an example here. This is a good one for me to show as an example in the IDE. Okay. This example of this circle with static numbers. Okay. Now, Nisa, you asked earlier about this whole public thing with the variable. All right. By default, the class variable method can be accessed by any class in what's called the same package. Now, we don't do a lot with packaging things here. That's a little bit more advanced than this semester will take us, right? But it is good to know how different things can be accessed. Okay. Now, public, if we make something public, it means any program anywhere can view the class. Okay. The class, the data, or the method. Private means we only want it to be accessed by the class itself. We don't want anybody else being able to get access to it. Okay, so we'll use the get and set methods. You'll see there the special name for those, the fancy name for those. It's called the accessor and mutator, getter and setter. Right. So we'll use get and set methods to see, to read, and change private properties. So for security, what we will do is we will make a variable in a class. Generally, we'll make a variable in a class private, but then we will have a public method to get it and to set it. Okay. So if we have, let's say, C1 here with a public X, no modifier Y, and private Z. If we create an object of type C1 here, this is in the same package, so it can access X because X is public. It can access Y because Y is what we'll call protected, or I think it's protected. Y is default. So since it's in the same package, it can see it. But it cannot access Z or Z because it's private. Only C1 can see inside, can see what's in Z. Same thing with the methods. You see, we can call method M1. We can call method M2. We cannot call method M3. Okay. Now, here we have a package P2. We create an object of type C1. All right. We can access X because it's public. We cannot access Y or Z because Z is private, so nobody can see it except for C1. Y is default, so because they're not the same package, he can't see it. And the same thing with the methods as well. Okay, and here in this example, if we don't put public on class C1, we just make it a class, right? Then because they're in the same package, it can access C1, but here, because it's not in the same package, it can access C2 because it's public, cannot access C1 because it's not public. Okay. For this course, generally, you will not use this default visibility modifier. We will want all of your methods and variables to either be public or private. And I can tell you almost exclusively, almost all the time, your variables will be private, your methods will be public. By making our variables private, we control what values they can get. So for example, Ozone, because it's actually this, I know it may be a little bit confusing. Oh, my mouse was over here on the wrong screen. I know it looks a little bit confusing. These are actually two separate diagrams. Notice here in this second one, class C1 is not declared as public. So for this particular example, these three go together and these three go together. Okay, I know that's confusing, and I think the textbook did this to us and messed us up this way. But the point is here is that you want to make your variables private so that you control what values they can get through get and set methods. All right, and so let's say, for example, you had a radius variable for a circle. You wouldn't want some user to come along and make it a negative value because that doesn't make sense. What is a negative valued radius? Right? Does not make sense. You would want to stop that from happening, and the only way you can do that is by making the radius variable private and having a public method to set the radius that then you control. If they pass a negative value to it, you say no, can't happen. Okay? All right. All right. So an object itself cannot access its private members. So for example, here we have a class C, right? C.x is used inside of the class and x is private. Here, however, if we have a test class where we create an object C, we cannot access x because it's a private variable. We cannot access convert because it's a private method. Okay. The object, if it's declared inside of its own class, it can do that. It can access its variable and method. Okay. This over here is a very rare thing. Don't worry about that one so much. This one, however, is very common where we will try to access a variable or a method that's private in a class, and we can't do that. Okay. We have to make sure that we know what we can and cannot access. What's going to happen is well, I'll show you an example of what would happen if we try to access a private variable or method. Okay. All right. Some reasons of why we might want to make a data field private. We want to protect the data from bad values. It also makes code easier to maintain. All right. We'll come back to this. All right. We've talked about this, the passing the value for primitive type. You know, the value is passed to the parameter. We can also pass value for reference type. Okay, so when we do that, when we pass, right, when we pass by value, the value is copied into our method. Here, the reference is copied into there. We saw this last semester when we talked about the swap method. So just remember that. Just remember the swap method from last semester. Okay. All right. Just like with a primitive type, we can create an array of objects. So here we're saying I want an array of circles of size 10. Same thing as always, same thing. We can assign a new circle to the array using an index. We can get information about a circle in the array using an index. Just like with the primitive type index, it starts at 0. Here. We have an array of circles, right? Circle object 0, circle object 1, all the way down to 9. Okay. Initially, when we just create this as a random new array, these are just all pointing to null. There's no circles. We just have to create 10 new circles and put them in the array. Okay. All right. An example we can show is how to do the total area, how to sum up the area of a bunch of circles. All right. Okay. We talked last semester. This is, you know what? I think I'm going to give you guys a break now before we talk about immutable objects in classes. We came so close to finishing this set of slides, but I also think that we've covered a lot of new material, and I just want to go ahead and give you those brains of yours, a moment to relax and just kind of de-stress and just kind of be able to absorb some of what we've talked about. So what we'll do is we'll take our break now. We'll come back at 2:33. Okay, 2:33. We'll start up again. I'll finish off these slides very quickly, and then we'll do some examples. Okay, so I'll see you guys in 10 minutes. And if you have any questions during the break, I'll be here. All right.